Hello, welcome you all. In this session, we will derive the response of the mass spring damper system when it is subjected to forcing function, that is forced vibration. Response of the mass spring damper system. Okay, we are deriving the response of the mass spring damper system in a viscous medium when it is subjected to forcing function. Okay, let us take a mass spring damper system. This is mass spring and damper. It is a piston cylinder attachment. When it is subjected to some force, let us say it is F0 sine omega t. F0 is the force amplitude. Okay, it is fixed at the top. This is the mass spring damper system. Okay, for this, when it is subjected to the forcing function, we are looking for the what is the response. Response means what is the displacement for different time. We know when it is subjected to forcing function, it will oscillate. Okay, so what are the forces encountered during the oscillations? Okay, this is free body diagram. The forcing function, it is downwards. If it is downwards, then all the forces are upward forces. Mx double dot, it is the inertia force. Mx double dot, if it is shown downward, then it is the accelerating force. If it is shown upwards, then it is the inertia forces. The magnitude of acceleration force and inertia force are same but opposite in direction. So the forces, this mx double dot, it is the inertia force here, and cx dot, this is the damping force, and this is spring force. Okay, for equilibrium condition, let us say mx double dot plus cx dot plus kx is equal to fn sine omega t. All the upward forces, that is equal to downward forces. The response of the system is equal to, it is a non-homogeneous equation, so complementary solution plus particular solution. For the mass spring damper system, we already know what is the complementary solution. That is, when mx double dot plus cx dot plus kx equal to 0, in that case x is equal to x e raised to minus zeta omega nt omega dt minus phi. Okay, it is already divided in the previous sections. Okay, this is the complementary solution. Now we need to find for this forcing function. Let us assume the displacement function a sin omega t plus b cos omega t. As we have accelerating component, velocity component and displacement component, let us find velocity component by using this displacement component. Differentiating the displacement component, we have a omega cos omega t minus b omega sin omega t. Okay, this is the velocity component differentiating the displacement component. Similarly, differentiating the velocity component, we get accelerating component, that is minus a omega square sin omega t minus b omega square cos omega t. Okay, let us substitute all this displacement, velocity component and auxiliary component in the differential equation of the system. That is mx double dot plus cx dot plus kx equal to f0 sin omega t. Mx double dot, x double dot is minus a omega square sin omega t minus b omega square cos omega t plus cx dot plus x dot is a omega cos omega t minus b omega sin omega t plus kx. Kx is a is sin omega t plus b cos omega t. This is equal to f naught sine omega t. Okay, let us separate sine component and cos component. Okay, in this we have sine component, that is minus m a omega square sine component, and here it is minus b omega into c minus c b omega, and here we have ka, and here it is f naught. Okay, as the sine omega t it is in all terms, it get cancelled, so we have this equation. Similarly, cos component coefficient, it is m b omega square minus m into minus b omega square cos omega t. Similarly, here it is ca omega, and here it is plus kb. There is no sine cos component, so it is 0 kb. Here it is ca omega. Okay, by this we'll find what is b. Okay, by the second, this is equation 1. Equation 2, by equation 2, b is, what is the quotient of b? Here, there are two terms with b, k minus m omega square. The quotient of b, it is minus m omega square, plus ca omega equal to 0. So b is equal to k minus m omega square. If it is goes this side, it is minus ca omega. So b is equal to minus ca omega k minus m omega square. So by this, a can be written as k minus m omega square by c omega, it is minus k omega square c omega. Okay, b is there. Okay, so this is a constant a. Let us substitute this value in the equation 1. So minus m omega square, this a value, it is minus of k omega square divided by cw into b, then minus cb omega plus k into a is this, is minus k minus omega square divided by cw into b. This is equal to f naught. So in all the terms we have b value, it is common. So let us take the same. Okay, let us take b common, and it can be simplified with taking the same LCM, c omega. So taking b outside, it is minus m omega square, minus minus plus k minus m omega square. B already it is taken outside. Then taking this LCM, c omega, it is not here, so it is c omega square. B it is already taken outside. Then this minus, it is taken outside, so it is k into k minus omega square f naught. So it can be written as b is equal to k minus m omega square. K minus m omega square, it is common in both these terms. So let us take k minus m omega square, it is common, and so what is left here? M omega square minus k. M omega square minus k minus c omega square, it is f naught, and this LCM CW, it will take right side, so it is multiplied with the f naught. Now k minus m omega square, if it is also written as k minus m omega square, then you take minus 1 outside, so it is minus k minus m omega square whole square minus c omega whole square. It is f naught c omega. In both terms we have minus out common, so you take minus outside, minus b k minus m omega square plus c omega whole square f naught c omega. So b is equal to f naught c omega k omega square whole square plus c omega whole square. This is the b value. Okay, let us substitute this b value and find what is a. Okay, a is equal to minus k minus m omega square b divided by c omega. Substituting this value, k minus m omega square by c omega, and this b value it is minus f naught c omega minus k omega square. Okay, we'll cancel the common cw, minus minus it is plus, so a value is equal to f naught divided by k minus m omega square whole square plus c omega whole square. Okay, this is a value. Okay, now we know that x is equal to a sin omega t plus b cos omega t. Okay, let us substitute the value of a and b. A value it is f naught k minus m omega square whole square plus c omega whole square sin omega t, this sin omega t, and b value it is minus f naught c omega k omega square whole square plus c omega whole square into cos omega t, this value. In this equation I just substitute the value of a and b. Okay, taking this term outside, f naught is also common, so f naught divided by k minus m omega square whole square and c omega whole square, we have, it is left with the okay, I made some mistake here. Okay, a value it is not only f naught, here it is f naught into k minus m omega square. Okay, so here it is f naught k minus m omega square. So the quotient of sin omega t it is k minus m omega square. Now it is sin omega t, and f naught it is already taken outside, so minus c omega cos omega t. Okay, now let us write this all equation in terms of sine function. So sin a cos b cos a sin b. Okay, in this fashion. So x is equal to f naught plus c omega whole square. Okay, sin omega t is there, so let us consider this as x cos phi sin omega t minus cos omega t is there, so it is considered as the sine function. So it can be written as f naught sin a minus b. Okay, in this fashion, sin a cos b cos a sin b, x is common. Okay, so what is k minus m omega square value here? It is x cos phi. K minus m omega square, it is x cos phi, and this cw it is what we have taken here, it is x sin phi. So by these two we'll see what is x. Okay, how we'll get x? Squaring both and adding. Squaring and adding and square rooting, we have x is equal to k minus m omega square plus c omega square. Similarly, pi value, it is equation 4 divided by equation 3, that is tan inverse of cw divided by k minus m omega square. Okay, let us substitute this amplitude in this equation and phi value here. So x is equal to f naught by k minus m omega square whole square plus c omega whole square, and x value it is minus k omega square c omega square sin omega t minus phi, it is c omega whole square. Okay, see here we have k minus m omega square whole square plus c omega whole square. Here also we have the same terms, but it is in square root. So what is the value of these two? We will combine these two. Let us consider this square root x, or we will take some other word, z. Square root of z divided by z. Z, it is nothing but 1 by 2. So it can be simplified as the minus 1 by 2. Okay, so we will write the square root of z by z, it is 1 by square root of z. So in this fashion we'll write. So it is f naught divided by square root of this term divided by this term. It can be written as like this fashion. Okay, you just go through this. Okay, why it is written like this, sin omega t minus phi. Okay, I have taken the same equation here. It is continued from here. Okay, it is x is equal to f naught by square root of k minus m omega whole square plus c omega whole square sin omega t minus phi. Okay, it is the same equation. Okay, now x is equal to dividing k. Okay, for the maximum displacement, sin value, it varies between 0 to 1. Okay, for the maximum displacement, when it is 0, then the displacement is minimum. When this value sin omega it is 1, then it is maximum displacement. So let us ignore, or let us consider the maximum displacement. In that case, sin value it is 1. So k minus m omega square by square c omega square. Okay, now dividing k value to the numerator and denominator, we have it is divided to all the terms. So f naught by k, it is considered as the zero deflection frequency. Zero deflection frequency. X is equal to f naught by k is f naught by k is x naught. It is taken in this notation. And k divided by k, it is 1. What is m by k? M omega square by k, where omega square it is written in this fashion. Omega square, k by m, it is nothing but omega n square. So omega by omega n whole square, already it is in the square. Then c omega by k, we already know that c by cc is equal to zeta. So what is c? Zeta into cc. So let us substitute c value as zeta into cc. C omega by k, where c is zeta into cc. What is zeta? What is cc value? 2m omega n, m by k. M by k, or it can also be written as k by m. Okay, k by m, it is nothing but omega n. This omega n and this omega, sorry, it is omega n square. this omega n and this omega n get cancelled, so it is 2 zeta omega by omega n. So it is 2 zeta omega by omega n, 2 zeta omega by omega n whole square. Okay, this is the response of the system. Okay, response of the system, mass spring damper system, when it is subjected to forcing function f naught, that f naught into sin omega t, damper system. Okay, if you know omega n zeta value, then this displacement at any time t can be calculated. So this is the response of the system for the mass spring damper system subjected to forcing function. Okay, thank you.